Okay,
Great.
got it. Okay. So back to this. So today I'd like to talk a little bit about how we can build healthy soils. So I came down here in 1978 and decided that I wanted to start a soil testing laboratory. And one of the things that I noticed when I first came down here was that we were all trying to grow subtropical fruits and tropical plants, but we're growing in an arid environment. And then what would it take to change the environment that our plants are growing in so that they could thrive in San Diego County? So first of all, that definition of soil, which is basically unconsolidated particles derived from weather, rock, organic matter, material, water, and air that forms over the surface of the earth. And the really critical piece to this is that when we talk about soil, it has to sustain plant growth. That's one of the definitions. So our goal is to have healthy soils because healthy soils support healthy plants. That doesn't mean that if you have something wrong or a completely healthy soil that you have everything in the right chemical range and you got good soil structure, that something won't come along and cause your plants harm, like an insect infestation or something like that. But what we do know is that if you have an unhealthy soil and a weak plant, that one of the things that will happen is that your plants will be a whole lot less able to withstand any kind of stress, whether it's from irrigation stress, salt stress, insect infestation, or plant diseases. So what are the characteristics of healthy soils? First of all, healthy soils have granular structure. They have organic matter that's suitable for the plant palate. They have nutrient and water reservoirs that are sufficient to meet plant needs, and they have friable, good tilth. So when you pick up your soil, it's crumbly, it has a nice dark color, and it doesn't have any obnoxious smells to it. Unhealthy soils are what we run into a lot here in San Diego County. They can be compacted with poor structure. One of our biggest problems is that they can have heavy salt loads. And this comes from mainly the irrigation water that we're using. San Diego County is at the very end of the Colorado River run, and we have about a ton of salt for each acre foot of water. And I recently read something that we have about 15% more salt in our water than we did 10 years ago. So there's a lot of reasons for that, but that is one of the issues. And it's also compounded because now we're using micro irrigation. And so it's a lot harder for us to flush salts out of our soil, like when we were using the big spinners when I first moved down here. So another issue that we have is that, again, we're growing tropical and subtropical plants, and those plants have are used to having a lot of organic matter in their soil, and our soils are arid soils, so they don't have a lot of organic matter, and that's one of the things that we need to adjust in our soil. And also, when we have as I said before, when we have plants that are planted under these conditions, we're subject to increased pathogen and pest pressure. So here's the challenges that we have in arid and desert soil. So we're not a desert, but we're definitely arid. We have the high salts, we have low organic matter, we have variable pH, we have some pH, high pH soils, especially in the mesas, which we'll talk about, but we also have really low pH soils. We have sporadic rainfall, salty water, and we have a lot of human activity. So this is a ideal sort of soil here. You can see the plants growing. We have this humus layer, we have a topsoil layer, and then we have a subsoil. And one of the issues that we have in our homes is that when they go through and decide they're going to build a house, the first thing they do is shave off all of this topsoil. And then the subsoil is also called the zone of accumulation. And that's because it accumulates clay and it accumulates salt. And so we have to go through and take this soil here and turn it into this soil in order for us to have really good growing plants. Um, it's also compounded by the fact that we don't have really deep soils in San Diego County. So our soil tends to be, you know, especially on south facing slopes, we have very, very little organic matter. So what I'd like everybody to remember today is that when we talk about soils, we have to make sure that we understand that the physical, the chemical, and the biological aspects of our soil are all interrelated. So first I wanted to talk about some of the physical characteristics of soil. And one of the characteristics of soil, physical characteristics, is texture, which is the percent of sand, silt, and clay. And texture can also be affected by the amount of organic matter in our soil. And really importantly is the structure of our soil. And so that's the arrangement of the sand, silt, and clay in the soil. Another physical characteristic that we have to pay a lot of attention to is compaction. And the reason that compaction is important is that if we have a compacted soil, then it's really hard to irrigate and it's really hard to get air moving through our soil. And that compaction also is going to affect drainage. So soil texture, I'm sure most of you have seen these soil triangles in the past. The soil texture is something that it's determined by the amount of sand, silt, and clay. And so if you have 100% sand in your soil, anywhere actually from about 86% sand to 100% sand, you're going to have a sandy soil. But we end up, if we have even as much as 60% clay in the soil, or actually 40% clay in the soil, then we can actually have a soil that's considered a clay. I'm going to stop sharing for a second because I wanted to share some of these soils with you. So this is an example. A lot of people always say, oh, they have the worst soil ever, but they really don't. This is like the worst soil ever. And this is some soil that, that I found at somebody's place. It's a really heavy clay soil. And the reason that it's really difficult to deal with a soil like this is that water can't move through it. And the reason water can't move through it is because the attraction of the water to the soil particle is actually greater than the force of gravity to move through. And so just to help put it in perspective, here's my beach ball. I don't know how well this works, but if you can imagine my beach ball is a grain of sand, the amount of this would be the size of silt, so about the 10th of the size of a grain of sand, but it takes thousands of clay particles to equal the size of one grain of sand. And so one of the things that we try and do is make sure that that we understand too, that sand and silt, they're solid. They don't really have any reaction in the soil. Clay is actually a crystal and it acts like a magnet in the soil. So what it does is that it holds ions, you know, the nutrients that we put in, as well as some of the salts. It's negatively charged, and so it pulls those in. So we have, I'm going to go back to screen sharing here. So when we have these soil particles, what we want to do is we want to take this clayey soil and we want to turn it into a granular soil. And the way that we do that is we do that through the microorganisms in the soil forming aggregates. And the way that this happens, and it doesn't happen overnight, there's 5 factors of soil formation, and the last one everybody always forgets about is time. It does take time. So when we add organic matter to the soil, we increase the microbial activity. And those microbes do is they don't live for very long. And what they do is when they die, they form this necromass. That's what gives your soil the dark color, and it actually binds the clay particles together. So we take these platy soils and we turn them into, combine, first of all, we make micro aggregates where we're binding the clay particles together, and they become relatively stable. And then they become the building blocks for the macro aggregates. So these macro aggregates, as your soil develops, would be bound together by hyphae, by root fibers and polysaccharides. And they also have another important function, that they reduce the bulk density of the soil because they're adding more pore space to the soil. And these pores are what allows for the infiltration of your of water into the soil. They're not very stable, so they're really easily subject to compaction. So when we talk about irrigating and being able to move water gravitationally through the soil, we also are pulling air into the soil, and that air is just as important as the water, because without the air, we lose the biology in our soil. So this is how the physical part of our soil is connected to the biology of our soil. If we don't have that air, we can't have the biology. So it's really important that once we start to form these aggregates, that we make sure that we don't compact. So again, the macro aggregates provide macropores, which provides drainage, which provides the ability to leach. It gives airspace, and it reduces water molds and root rots. We're going to talk about the ability to leach and how important that is in San Diego County in a few minutes, because that's related to the chemistry of our soil. So when we talk about improving soil structure, as a pre-plant, if you're just starting out with new soil, you can add compost to the top 6 to 8 inches of soil, mix it into the top 6 to 8 inches. It should be well composted. It should be at least 3/4 inch minus, and it needs to have a carbon to nitrogen ratio of less than 20. And that's super important, because if it's more than 20, we tend to tie up nitrogen in the soil, and that's not good for our plants. So the other thing that you can do to improve soil structure, especially if you have trees, would be to use mulch to prevent compaction. And you need at least 2 inches of mulch to do that. I like to use a composted mulch, because as it breaks down, it will add organic matter, carbon, to the soil, which helps feed those microbes. And we want to make sure that when you do use mulch, you keep it away from the crown of the plants. And another thing that's really important is to avoid working your soil when wet. Don't go walking over it or moving equipment over it. If you have mulch down, that really does help prevent compaction, but never till a wet soil, especially like right after a rain. So when we talk about the biology of our soil, one thing that I always think is really interesting is that with a lot of plants, the biomass under the soil is actually as much as the biomass above the soil. And a lot of the organic matter, as we, especially with trees, as we get our plants well established, as roots grow, there's a lot of root sloughing, and that root sloughing adds a lot of organic matter to the soil. So once we get into a good cycle, you don't need to keep, tilling in organic matter. Just putting some mulch on top of it every year or so, it will help maintain the organic matter in the soil to feed those microbes. So there's all sorts of different kinds of organisms. Bacteria are super, super important, because those are, especially if you have a clay soil, because that's what will give you good soil structure. As they utilize the organic matter, which is their source of carbon in the soil, they will form those macro aggregates, and then the fungi, actinomycetes, they will help form the macro aggregates. Earthworms and insects also are super important because they again help provide or help develop those macro aggregates. And some earthworms that move up and down the soil actually help move air deeper into the soil. And then there's the specialized microorganisms that we always talk about, which are the mycorrhizae that enable plants to mine the nutrients that they need from the soil, and also nitrogen fixing bacteria, which if any of you are doing annual gardens, it's great to to use a legume now and again, or to use cover crops that have legumes in them in your orchards. So like clay, soil humus, colloidal humus in the soil has the ability to attract water and plant nutrients. So the cations, but it also can attract and hold anions. So it actually chelates some of these nutrients so that we don't get leaching, and it's more available for plant growth, especially phosphorus. So one of the strategies that I like, and this relates to the chemistry that we're going to talk about in a little bit, is when you put on mulch, especially now is a great time to do it because you can do it before the winter rains, and mixing some of the fertilizer like phosphorus in with it, which doesn't leach, but will be more available for plant growth in the spring. And also the humus itself aids in the formation of soil aggregates. It's what gives our soil its dark brown color. Again, when we use that mulch, it not only helps reduce compaction like we already talked about, but it also acts like a sponge, and this helps absorb weight and water. One of the most important things, though, is that it helps prevent erosion, because when we have mulch on the ground, it shatters raindrops. And when we shatter raindrops, it's the rilling from raindrops that causes the erosion. So this actually helps water infiltrate slower into the soil. And again, it supplies food for the microbes, which encourages the micro and macro aggregation. So the next piece of that, we talked a little bit about physical and biological characteristics of your soil. And we talked about how those are tied together, because without good soil aggregation and good drainage, we don't have the air movement through the soil to support all the microorganisms that are needed. So when we talk about chemical characteristics of the soil, which is going to tie into those two, talk about pH and salinity and nutrients. And a lot of this is related to the soil chemistry, soil and water chemistry. So I mentioned earlier that the salts in our water some of them are good and some of them are bad. So there's the beneficial ones, which are potassium, calcium, and magnesium. And those are cations. So those are the ones that are attracted to the clay in our soil. And then the sulfates and the nitrates, which aren't. But they move through the soil move through the soil profile with the waterfront. But there's also some damaging ions. And so the cation that's damaging is sodium. And the way that sodium damages our plants is that it affects the physical ability, or the ability for the soil to physically aggregate. So you're more prone to compaction, but it also affects plant growth. And plants have a problem with excess sodium, just like some people do. And basically what happens with it is that it tends to accumulate at least in trees, tends to accumulate in the roots. And then it's dumped all at one time into the plant, into the leaves, and you'll see sodium damage. We don't have as much sodium in our soil as some other waters do, and it's really kind of balanced by the amount of calcium that's found in our water. But what really gives us a lot of damage is the chloride. And the reason that chloride gives us problems is that it's taken directly up into the plant. The plant has a really hard time excluding it. And the sodium in our water, or sorry, the chloride in our water is actually some of the highest chloride water in any municipal water systems around. And that's mostly because of where our water comes from, which is, you know, coming over arid desert lands, and it goes directly into the leaves. So when we're growing, especially tropical and subtropical plants, they're really not genetically able to tolerate the amount of chloride. And so what we end up seeing is burning on the tips of the leaves. It's accumulated in the plant at kind of a steady rate throughout the growing season. And then when we tend to get the hotter weather like we have had the past few weeks, where it's hard to get enough water on your plants, you start to see the tips of the leaves, especially on the older leaves, because they've had more time to accumulate it, but the tips of the leaf turning brown. And the only way that the tree can get rid of that chloride is for it to drop the leaf. So even if we have evergreen trees that aren't, that shouldn't be losing their leaves, we tend to lose our leaves prematurely, and that's not beneficial to the plant, because the leaves are like the factory for giving our fruit all of the nutrients that it needs to grow. And then the other problem that we have is boron, and I haven't really seen a lot of problems with boron. I don't know if any of you had. I'd be interested in hearing that. But I'm going to stop the share for a second. So I took the sponge and put it by my sink for a few days, and just added a little bit of water, just our Colorado River water that comes out of my tap, to it, and then let it dry, and then watered it again. You can see how the salt precipitate accumulates here on the edge of the sponge where it dries first. So when you put the water on, it's just like when you water your plant. The water pushes the salts out, but at the margin of your irrigation plant is where you tend to start building up those salts. And so being able to, I'm getting feedback. Is anyone else getting that? Okay, so
Amina needs a get her microphone up. Maybe you can turn it off, Mary?
Hold on just a second.
Amina, you can see the little.
Oh yeah, okay, got it.
There you go.
Got it. Okay. So I'm back. Okay, so basically what we have now is the salt accumulating. And so especially if you have micro sprinklers and it gets windy out and you have your irrigation on, one of the things that can happen is that your irrigation will push the salts, or push the water flow and push the salts back into the root system. And that's also one of the reasons that I think we see more damage in August and September from the salinity. So the trick is being able to irrigate heavily, you know, at least once a month or so that you move those salts, you know, further out away from the actively growing roots. And it doesn't have to be done that often. People often say, well, if my water's so salty, how can I leach with that same irrigation water? But if I put this underneath my sink and give it a good dousing, it's going to move a lot of those salts out. And the soil really does act very similarly. So let me go back over to, can I ask if anybody has any questions about that before I go any further?
So would it be beneficial to put like a water filter on the garden hose? Would that help?
No, because these are dissolved salts. And so if you had a filter, would work if you had solid particles. But if you can imagine, say, dissolving just some table salt inside a glass and then filtering it, then then you would only be able to filter the solids out. These are dissolved solids. So it doesn't really work. You can use things like reverse osmosis, which is really, really expensive. But fortunately, one of the things that happens is that if we get even 4 inches of rain, it really does help to move the salts down into beneath the root zone. One of the advantages of a lot of subtropical and tropical plants is that their roots really are, their feeder roots are pretty shallow rooted. So it doesn't take that much water. 4 inches of water and a fairly short, close together is really enough to start you off with a clean slate at the beginning of the growing season.
I had a question also, Mary. What about, I grow most of my fruit trees in big, big, big pots. So how does what you're saying relate to pot culture? Or, I mean, I do have
Pot culture is a lot different. And so you're able to control a lot of the variables better. So what kind of soil did you use when you first started with the pot culture?
I generally use the Kellogg's organic, I can't remember what it's called, or Kellogg's organic patio plus potting soil.
Yeah, so that already has, that's like a sandy loam soil or loamy sand soil, sandy loam, that has a lot of organic matter and shavings and all sorts of stuff in it. And so it's really kind of an artificial soil in a way. It's not like starting out with a mineral base and then putting it on. So you don't have to worry about a lot of these things.
And as far, I'm sorry, as far as like flushing out the salts,
it's a whole lot easier for you to do that in pots.
Okay.
Yeah.
Thank you.
Yeah. So you're good on that one. Anything else before, because I know everybody wants to talk about pH. So anything else before I go on to pH?
Is there any way to battle chloride?
Chloride really moves through the soil. So just doing the leaching, John, being able to go through and apply 50% more water during a single irrigation session will really help move that chloride. So that's my general rule of thumb, is every 4 weeks apply about 50% more water, and do it when there's no wind, because with again the micro sprinklers that we have now, they're really easily distorted with wind, and so it kind of is difficult if it's windy out to do that leaching. So doing it really early in the morning is a great idea. Okay, I'm going to go back over.
And if I could ask, if I do finally get my drip irrigation going on my pots, then it sounds like I might be at risk of having the salts accumulate if I'm doing just the drip irrigation.
Yeah, but then just go over with a hose and give them a good dousing once a month.
Gotcha.
That'll do it.
Thank you so much.
That'll take care of it.
Great.
That'll take care of it. Yeah, pots are a whole lot easier to control these variables when you're growing in pots. That's for sure. Okay. So now comes kind of the chemistry part here. So I talked about how the clay particles and also the colloidal humus particles, as your organic matter breaks down, they act as a magnet. So they're holding on to all of these positive ions in the soil, everything that is positive. So Na stands for sodium, if some of you have forgotten your high school chemistry. So the sodium is the one that we're kind of concerned about building up in our soil, and the hydrogen is what we're really concerned about, because a lot of the subtropicals that we grow, really want to have more of a acid environment. So the clay particles acting as a magnet, negative magnet, are going to hold things like the sodium, the hydrogen, aluminum, which we don't want a whole lot of, potassium, which is really important for fruit production. And also the other thing potassium's super important for is the good operation of the stomates on the bottom of your leaves, which control how much water is transpired. So it's really important that you have adequate potassium there, magnesium and calcium. So those are all going to be on the soil. What happens is that if we have a lot of calcium, magnesium in the soil, we tend to have all of those magnet sites, you know, that we can hook up on the clay particles or humus occupied by them, and we don't have any room for any of the hydrogen. And these are going back and forth when you water, and some of it's soluble, and then some are being taken up by the roots. But the problem is that the hydrogen is what determines the acidity of our soil. So that's what pH stands for. It is the hydrogen ions in the soil solution. So that soil solution is this stuff right here. So if we have a lot of hydrogen ions in the soil, our soil is more acid. And if we have more hydroxyl ions in our soil, it's alkaline. So a lot of our soils in San Diego County and in the mesas are kind of in this alkaline range. And what we really want for most of our subtropical plants are because they're in weathered soils generally, because they get lots of rainfall. So what we really want are the low 6s to 6.5 and even 5.5. We have a lot of our tropicals doing well in those in that pH range. Where we run into a problem is where we get up in the 7.5 to 8 range, and especially when we get into we have excess carbonates in our soil. So I don't know if any of you have ever tried this, but one thing that you can check to see in your soil that if you have excess carbonates, what happens is that it inhibits the uptake of things like iron and manganese, you know, the micronutrients. So you get yellowing on the young leaves. We do tend to see that in the mesas. And a really simple, easy test for you. I'm going to demonstrate this here. So hopefully you can see it. Can you guys see me? Can somebody let me know? Yeah, okay, you can see. Because I can see Linda, but I can't see anyone else. Okay, so what I have are two different soils here. Can you guys see those? I have a screen protector on my laptop, or a keyboard protector. I've learned that the hard way. And what I have here is vinegar, and this works really well. And so what happens is vinegar is an acid, and if there's excess carbonates in your soil, you're going to see it fizzing. So all you have to do is just get a little of your just any kind of vinegar and just put it on the soil. And I don't know if you can see that, but on this first soil that I'm putting it on, there's no fizzing.
Raise the plate higher. There you go.
Okay, so there's no fizzing. And then when I put it on this part of my soil, can you see it fizzing? And that means that there's carbonates in your soil. I'll try that again. I don't know if you can see that, but you can do it at home. I mean, you'll see it fizzing. All you have to do is just put a few drops of just regular old vinegar on your soil. And that's one of the things that's really important for you when you're determining how can I modify my soil, is if it has carbonates in it, it's going to be a lot harder to modify. Okay, So you can see that as the soil becomes more acid, that you're seeing more of these metals, the iron, the manganese, the copper and zinc, they become much more available. And as it becomes more alkaline, like I just talked about, it becomes less available. Now, one of the problems is that what that we see with subtropicals is that it's a fine line between, an adequate pH, and really anything in between 5.5 and 7 is going to be okay. It probably is not going to be a limiting factor in how your plant grows. If you get below this 5.5, you're losing so much of your calcium because the hydrogen has taken the place of the calcium and the potassium and the magnesium on the clay particles, that now you don't have enough calcium, potassium, and magnesium necessary for plant growth. And we find that that's when we start to see evidence of more root rots, is when we get down under this 5.5 or 5 range. And we cure that really easily by adding calcium carbonate in the form of lime. The other thing that's important to remember about the soil pH is that 7 is neutral. So we have the hydrogen ion and the hydroxyl ion, and that together is H2O and water, so that's neutral. But this is a logarithmic scale. And what that means is that at a pH of 6, we have 10 times the hydrogen ions as we do in that soil solution as a pH of 7. And we go down to 5, that means we have 100 times more. And when we go down to 4, we have 1,000 times more. So there's only so much room on that exchange capacity that we just looked at. So if we put hydrogen, too much acid in the soil, it bumps off things like the potassium and calcium and magnesium. And again, that's no good for your plants either. If any of you get a chance, there's a really good example of a super acid soil. It would be over here somewhere, about 2. And it's exposed sometimes during construction. And it's called the Del Mar Formation. And it's basically an ancient sulfur marine layer. And if you are driving north on the Interstate 5, and in between Manchester and Birmingham, they're doing a big revegetation project. If you look closely at it, but not too closely, especially, well, you can look closely if somebody else is driving, but if you look closely at it, you'll see some areas where there's some kind of red bubbling out of the soil, and it's turned the soil red. And that's where this Del Mar Formation has been exposed. And what's happening is it is so acid there that the iron becomes soluble. And then when it hits the atmosphere, it oxidizes and it turns into rust on the soil. So it's kind of interesting if you get a chance to look at that. So when we talk about adjusting the pH of your soil, the first thing that you need to know is the pH of the soil. You also need to know the texture of your soil, and you have to have an idea of what you want your target pH to be. And you also should know if carbonates are present. And that was that little test we just did with the vinegar. So we're going to talk about the texture first, because we mentioned that before. And I'm going to pull up another thing here. So we look at this guide. This is when I taught soils. This was something that we used, and this is just as easy to do as, or it's just as accurate really as a laboratory test. But basically, this is a flow chart, and it's giving you just yes or no answers along the way. But the really important part here is to determine whether you have clay in your soil. Because if you have clay in your soil, it takes a lot more sulfur.
Your flow chart,
What was that?
We're seeing just the PowerPoint, not the flow chart. I think you've only shared your PowerPoint.
Oh, no. Okay, hold on just a second. Sorry about that, you guys. Okay. So it says when I tried this earlier, I was someone. Okay, so can you, do you just see a PowerPoint right now?
Yeah, it's back to the healthy soils and support.
Okay, hold on just a second. Okay, give me just a sec, you guys.
Janae,
Yeah, ask questions while I figure this out, okay? Sorry.
Does the vinegar test really work? There's some- you put it out to the soil and put vinegar on it, it starts fizzing.
Okay, you know what? I apologize. I don't think I am going to be able to share the share that, but I actually have it, John, as I have it as a list of attachments that I can send to you. If you can post it on, do you post on Facebook? Is that it?
Yeah, we post on Facebook, or we have a direct line to members.
Okay.
Yeah.
I'll email that to you after the meeting, okay? I made up a sheet of the resources that I'll show you at the end of the show. But basically what you're looking for is to take that soil in your hand and add enough water to it, make a ball, and then see if it ribbons. And if it ribbons more than an inch, then that is the that's going to be the determining factor. And unfortunately, so this is the bad part, because one of the things that I was sharing with you was a something from the National Gardening Association that tells you, once you find out what type of soil you have, whether it's clay, sand, or loam, and you put in your existing pH and then what you want your pH to be, it tells you exactly how much sulfur you need, which I think is a great tool. So I have a link to that in my stuff, but unfortunately, I will not be able to show that to you. So what we can talk about though is, let me just go back and share the
While you're getting that queued up, what do we do if our soil fizzes with the vinegar? How do we address that?
That's what you're going to do. You're going to have to add sulfur to it.
Add
And so the sheet that John will make available to you has a link to that website that'll tell you exactly how much sulfur to use.
Gotcha. Thank you.
Okay, so the next thing that we're going to talk about was testing the pH of your soil. So there's laboratory tests that you can do, and on that link sheet, I've given you the name of 3 laboratories that can do testing. I know it's expensive. It's generally runs in the neighborhood of $100 for a complete soil test. But, you might want to ask for one for Christmas or for your birthday or something. The other one that you can do is home testing. And John and I had talked about this the other day. And so I went out and I got a whole bunch of different kinds of soil testers from Amazon. And I thought I would just run through them because I tested them against a laboratory test to see, well, do these really work? And the answer in general is yes, they work, but there's some caveats with it. So the first ones are these kind of rapid tests. This particular one, and I have links to this on that sheet that John will send you. So this rapid test one here, it is basically, oh, they're right here in front of me. So the pH tester, all you have to do is put a little bit, can you guys see this that I'm holding up?
Yes.
Okay, good. Okay. So basically what you do is you just put a little bit of soil in the bottom. You add distilled water, and I want to make sure that you understand that it's really important to use distilled water here. So if you use our Colorado water, there's so much salt in it, and it's been treated with chemicals and stuff that it really throws things off. So this test here is one that you just add a little, hold on, sorry about that. You add this little powder that comes in a little capsule to the soil, and then you fill it up with distilled water, you shake it, and then you let it settle. The problem with these is that if you have any clay in your soil, it stays suspended. And when it stays suspended, then the problem with that is that it's cloudy and you can't really distinguish the color. So I tried it on a few different soils and wasn't particularly happy with it. This is sat now for about an hour, and you can see that it has turned green, so it's showing a pH of about 7. I don't know if you can see that on the screen, but that's one option that you have. The other one was something that's kind of similar to that, where you put the water in, you put your soil in, you put the water, the capsule in, and then you put your water in, shake it up, and then it goes in this little spectrophotometer here. And then you just press the button, and then it tells you what the pH is. And this says it has a pH of 7. So it could be anywhere from 6.7 to 7.3. That's about how accurate any of these are. But I think that's really about how accurate you need to be. You just want to find out if it's over 7, or if it's close to 8, or if it's under 6. It doesn't have to be that accurate. And then the other one that I tried were these pH papers, and they come in with a little strip here. And again, one of the problems with it is that there's so much, if you have any amount of clay in your soil, it turns it brown. And so it's really hard to read them. But what I did, I played around with it a little bit, because I know that, like, if you have a lab, you can just filter it and get that out. But what I did was, not having that, was just to use a little Melita coffee filter and then filter it so it wasn't cloudy. So this is what it ended up looking like when nice and clear. So this is a pH meter, just a little handheld one that I had laying around. And you can see that this is showing a pH between 6.6 and 6.7. So they're pretty darn close. The problem with using a pH tester like this is that you have to have all these different buffer solutions in order to calibrate it. And when you have to calibrate it like that, the buffer solutions only last a year, and it gets kind of expensive. So you could be spending, $50 or $60 on all of this setup and only use it in a very limited manner. The pH papers, though, let me see. The pH papers you just dip in and get them nice and wet, and then you just compare it. I'm going to see if I can hold this up for you. You compare it with the colors on this, and so this one is coming in at around 6.5. So they're all pretty close. The main thing is that to make sure that you're using distilled water, and if it's cloudy, to filter it. And I found that just the Trader Joe's little coffee filter worked fine. So does anybody have any questions about that? Questions about soil pH testing? I think it's a pretty worthwhile thing to do, just to find out if there is a problem. And then the big question is, well, how do I correct it? And so the way that we correct and ask a pH that's too high is that we add soil sulfur. And the best way to add soil sulfur is to mix it with whatever organic mulch you're going to put down in the winter, and then go ahead and put it down, let the winter rains move it in. And in general, what you're talking about is somewhere, depending on what your pH is, and you can use the little chart that that John will send you, but it'll be somewhere between 3 and 5 pounds per 100 square feet.
So is that the same as lime?
No, lime makes your soil more alkaline. So it's soil sulfur that makes your soil more acid, and it's lime or calcium carbonate that makes it more alkaline. So don't get them mixed up. And we don't tend to see a lot of problems with soils that are too acid in San Diego County, especially for tropical or subtropical fruit.
If you've been adding mulch over the years, will one test in one place work, or do you need to do multiple tests in various areas of the yard?
Well, so that's a great question. So in general, if you've been using the same irrigation water for years and you've been using mulch along with it, your pH is probably going to be pretty darn the same throughout the yard. If one of the things though that we like to emphasize, or I like to emphasize, is it's really important on how you take your soil sample. And so that was the other thing I was going to show you. I thought I'd be able to share all of the stuff with you, but you can link to it after the meeting. Let me move back over. It's in taking a soil sample. Let me go back to share my screen here. So that's the home testing. So the soil sampling, that was what I was going to talk about next, is that usually we want to sample using a soil probe. And each sample, if you're going to take a sample and send it to the lab, you're going to have to take 12 to 20 cores and take off the top leaf mulch layer from that. So that's pretty important. If you're just sampling inside your yard and you want to test under a particular tree, and you get one of these kits that has 100 test strips in it, then you can play around with it and take a whole bunch of soil samples and test for pH and see how they compare. But it's super important if you're going to spend the money on. Can you guys see this? Can someone let me know if they can see what I'm holding up?
We can see it.
Okay, good. Okay, so it's really important to use a soil tube when you're sampling, and the reason is that it gives you a really good representative core through the soil profile. And if you just take like a couple trowelfuls of soil, it may not be representative. So like I have my technique, which I use all the time when I'm soil sampling. And that is that I always take my sample between the tree and the emitter, midway between the tree and the emitter and irrigation emitter, and take at least 15 core samples taking off the top inch, because that's usually where the mulch is, taking off the top inch and send that into the laboratory. Now, I know that those soil tubes are expensive, and one of the links that that John will send you talks about how to sample in detail. And I know they're really expensive, but it's also an excellent way of evaluating soil moisture, and which is super important in San Diego County, is understanding how and when to irrigate. And so this is going to be one of the best tools. And if you have a densely planted orchard, they're really nice in the fall. If there's a lot of spider webs, you can kind of knock off the spider webs when you walk through. But they do cost about $150. And so I do know that that's expensive, but I bet you some of you at least have people that say, oh, I never know what to get you for Christmas or for your birthday or whatever. And so getting a good soil tube is a great idea. And so these are the links that John is going to send over. Can you guys see those? And so,
Yes, ma'am.
oh, got it. Okay, so like the first one, I don't know. I might be able to tell. Oh, it won't let me do it from Zoom. So, but these are the first one is that link to the National Gardening Association, and that is one of the best. When I started doing some research for this, that was one of the best resources that I found as far as lowering your soil pH. And then the next one is how to take a soil sample. This will if you are going to spend the money and get a soil test, then I highly recommend that you follow that pretty carefully, because the sample's only as good as the your results are only going to be as good as the sample that you took. And then evaluating your soil texture is the link. Whoops, the link for the texture by feel. And then also I put in that chart that I showed you earlier about the nutrient availability according to pH. And then these are the test kits from Amazon that I tried out. And if the first two actually have different, you can also test for nitrogen, phosphorus, and potassium. So if you were, they're only about $15, and I think you can do about 10 of each test with them. So that would be something kind of fun to play around with too. And then this, the soil pH test strips, there's 100 tests in that one. And then if you do decide that you would want to go to have a soil test taken, I put down some labs, and these are all people that I've used. The San Diego Agricultural Lab, that's in Fallbrook. I put their websites down there so you can see, like how much it costs and, what their submission requirements are. Summit Horticultural Consultants and Wallace Labs. So probably the first two have reports that are going to be much easier to read than Wallace Labs, which is just the numbers, which is kind of tough sometimes for people. So that pretty much was what I was going to talk about. So does anybody have any questions?
I think you covered everything. You did really
Ken.
good. Yeah.
Thank you.
Yeah, so some of the links I sent you to are from my website. So my email is on there. So if you do run into any questions, I always love to talk about dirt. So send me an email and I'm happy to answer any questions. I think I saw a couple of questions here.
Mary, that was your company though? You do the big trucks, the semi trucks, and then you blow the mulch into a property? That was your company?
Yeah, I don't know how I got involved. It started out as just I wanted to do the composting. I had a lab, right? So I was doing that. And then I thought, oh, well, this sounds like fun because everybody had to start recycling. And then somehow it grew and grew and grew. And so now we set 1,000,000 tons on that, but we've really done 2,000,000 tons of material. And then
Wow.
we have, a lot of people would say, oh, I can't really apply mulch because, it's hard to get in. And I thought, oh, well, these mulch blowing trucks, unfortunately, they're like $500,000 each. And
Wow.
they're the most persnickety pieces of equipment. I mean, we have to have like a full-time guy working on the specialty equipment, but it really works well for landscapers because they don't have the personnel. Everybody's really struggling to get enough people to work right now. And so it really helps them. It's cheaper for them to have us come out and do it than to take their labor, which they have a hard time getting enough labor sources to be doing things like spreading mulch on slopes and stuff. Plus,
Yeah.
we can do about 60 yards in about 3 hours. And it would take a lot of guys a long time to do 60 cubic yards of mulch.
Yeah.
So Paul had a question about how deep do you need to take the soil core? And one of the things is that we're really looking at the active root zone of the plant. And most of that, remember when I was talking about the air and water transfers in the soil? Most of the nutrient uptake, especially on subtropical plants, is going to be in the top 8 to 12 inches of the soil. So that's all the deep that you need to go, when you're assessing, things like pH and nutrient availability. And then Keo had a question on how can compost help the soil. And so what compost does is that, compost in itself doesn't really help the soil. What it does is that as it breaks down, and the reason it breaks down is because microbes are using it as their energy source. It's the microbes that, as they use the organic matter in the compost, use that, and then the microbes go through their life cycle. It's that the dead microbes are what bacteria are, what are gluing those clay particles together, forming those micro aggregates. So it's really, really important. And I don't know, have any of you ever listened to Science Friday? No? I guess I listened to the nerdy podcast. But Science Friday had a thing on a couple of years ago, and it was this lady up in that was studying the organic matter in Alaska. And I never heard it before, never really thought about it, but she referred to it as necromass. So what gives your soil that dark color really is the dead bacteria and microorganisms. And so she referred to it as necromass. So that it's the food source for our microbes. And as the microbes break down, their exudates also are help with the help with that formation of soil microbes. And then I have from Ellen, is the best strategy for farming and gardening and climate change increasing the protection of the roots by increasing mulch and biological activity in the soil, facing 118 Fahrenheit temps and above lately. And I'm sorry to hear that, because I used to have a compost facility out in the desert, and I take the heat as well as our subtropical plants do. So that is a really tough place to try and grow when we get those hot temperatures. But the thing that when I had the soil testing lab, the thing that really got me interested in mulch back in I'd say it was probably the mid to late 80s, was I was working a lot out in the desert with citrus growers in the Coachella Valley. And I don't know if any of you have spent time out there, but when you drive around, you get these fantastic views of the different elevations in the valley. And everything out there kind of always looks yellowish in the summer. And we were out driving around, and I could see in the distance, there's this one area that had really dark green citrus trees, lemon trees, in the middle of an orchard out there. And when we went to investigate, drove a few miles to see what was different about that, it turned out that that area had been mulched. And it was amazing just how it helped moderate what the plants were doing and how they were utilizing water. And so we had, even just reducing, keeping the soil temperature in that top where those feeder roots are nice and cool. But it's amazing how much mulch really does help in those warmer temperatures. And the compost facility out there that I had, we would sell out of composted mulch for grapes, because it was amazing how it really did help with how the plants utilized water. So I would say, mulch, make sure, but make sure there's no other limiting factors, So I like to put the mulch on in the winter, like I said now, mix some gypsum in with it. If your soil pH, if you want to lower it, mix your soil sulfur in with it and spread it out and let the rains move it in. I mean, that's how Mother Nature develops soil, is by that organic matter breaking down and moving into the soil. And I think you'll be really surprised if you get it on before those rains happen. Did that answer your question, Ellen? Up. And then Mark, great. Okay. And then Mark asked, what's your opinion of using mushroom compost and compost from the Miramar Greenery? And then you say salts. There is more salt in the mushroom compost, but a lot of it's good salt, because they're putting in gypsum and they're putting lime in it. And, there's all these calcium salts that they're adding. The first time that I did a mulching project on avocados was in the early 90s, before I started composting myself. And it was out in Palma Valley. And I wanted to see, what I was trying to do was to mitigate salts, because I talked earlier about when those leaves fall prematurely, they become really hydrophobic. So you get chloride, it's kind of like this spiral. So if the plant takes up too much chloride, the leaves fall prematurely, and then you get this leaf layer. If any of you have avocados, you probably see that. And so then it gets really difficult to get water through that leaf layer, especially when we're using micro irrigation. And so I noticed when I was out looking at avocados, a lot of times it would take hours before the water would penetrate, because the leaves are really hydrophobic, before they would penetrate. So what I was looking for was a mulch to put on top of the leaves, so that the water would immediately go into the mulch, and it wouldn't be lost to evaporation. Because as soon as you start to evaporate water, then essentially you're increasing the salt content. Does that make sense? So putting mulch down really did help with that. And Mark, the mulch that I used came from mountain meadow mushrooms, so for that project, and we didn't see any damage from salts with it. The trees did fantastic. So it's just a question of putting it on before we get those winter rains and letting that flush the damaging chloride salts out. Did that answer your question? Okay, and then you asked about Miramar Greenery. Miramar Greenery, they basically do the same thing that my business does. They take in green waste and some food waste and and turn it into mulch and compost. So they're regulated by the state, just like we are. We get inspected once a month, and we have to take pathogen tests to make sure that we're killing any weed seeds. We're killing, if people rake up dog poop. The other advantage is that when you go through this composting process, if somebody's used a pesticide, the pesticides break down during that composting process. So, you know, you don't need to worry about that. So Keo has another question. How much mulch and compost should be applied to the soil? Um, I like to go with.
No,
It's stuck.
isn't the gum is like loosely attached?
So what I like to do is use about 2 inches of mulch. I don't think you need to use more than that. Some people say, oh, you should be putting on 4 or 6 inches of mulch, and that's an awful lot of work. It's really the interface between the soil and the mulch that makes a difference. So I'd rather see you put less mulch on a bigger area and then just dress it up occasionally than put it on really thick. And it's really important to keep it moved away from the base of your trees, because if you have mulch up against the base of the tree, it will hold moisture, and that can lead to crown rots, and we don't want that. Did that answer your question, Keo? Excellent. Does anyone else have any questions?
Mary, you talked about the 20 ratio with compost for it to work. So I think the compost to have a ratio of 20, I believe it was.
Oh, the carbon to nitrogen ratio. Right.
Yeah. How can you check that? Or is it just natural, shredded?
Yeah, so 20 to 1 carbon to nitrogen ratio. If it gets much higher than that, if it's gone through a process like Miramar Greenery or myself puts it through, we have to heat up our compost in order to kill pathogens. So we're regulated. We have to keep records on the temperatures. And so in order for it to heat up, it will have a ratio of 20 to 1 at least. So as long as you're getting it from a composted product, you don't really need to worry about that. What we don't want you to do is to mix something into your soil that has a carbon to nitrogen ratio of less than that. So you wouldn't want to mix fresh wood chips in. That would be a problem. Finished compost will be less than 20 to 1. A brush mulch, which you can put on top of your soil because nitrogen doesn't come back up out of the soil. So it's not a problem. It's only a problem if you mix it in. But a brush mulch would be like 60 to 1. And if you just put wood chips down, it would be like 300 to 1. So you would never want to mix wood chips in with your soil. That's kind of a disaster.
Great, thanks.
So Mike asked if you can just place compost. Thank you very much. Mike, you wanted to know about no-till use with compost. I like using, if you're going to use a no-till approach, the problem with putting on a 2-inch layer of compost is that it's so fine that water has a hard time getting through it. So you're better off using a composted mulch. We have one that we call Ag Grind, and we use that as, because it has some bigger pieces in it. So we use that and it goes just on top of the soil. But we also have some of our growers, some of our commercial growers that use that in place of compost and mix it in. But it's a little bit coarser than our fine compost. I know the general rule with them is that you have to have this really fine compost before you mix it in with the soil. But a few years ago when I was in Germany, I always go to landfills and farms. But a few years ago when I was in Germany, they were using what we now call Ag Grind, and they were actually using it on tomato crops. So I've got one grower that uses it for potatoes. He grows the best potatoes, and acres and acres of them here in San Diego County. And then some of the flower growers also use it and just till it in. and they use it at the rate of like 10 tons to the acre. Barbara asked, is there a way to kill pathogens in existing soil? So it depends on what kind of pathogen it is. And it depends on the susceptibility of that pathogen to, or the plant that you have to the pathogen. So Barbara, is there a particular pathogen that you're asking about? I have something turns black and dies. Are the roots, are the feeder roots brittle? I don't know if we can unmute Barbara so she can talk. Ask to unmute.
She just has to click on her microphone.
Barbara, can you click on your microphone? There you go. No, I guess not, maybe not. So Phytophthora root rot is the most common disease on avocados. And that is a really tough one to, that's a really tough one to control. So if you have well-drained soil and you have, and you're watching the water on it, we've seen some decent results with using mulch, like that ag grind mulch, and also adding some gypsum to that. It won't affect gypsum doesn't affect the pH of your soil, but a lot of times we're lacking in calcium, or the plant's having a hard time pulling up enough calcium. And if you have like a DG sort of soil, and that will help. But we've also seen Phytophthora root rot be really difficult to control, especially in a soil that that has a really, really low pH. And in that case, you may want to lime it. So the first thing to do would be to test the pH of your soil, and then mix whatever you need into it. It'd be interesting to find out if you had been using any phosphorus fertilizers, because there's this kind of myth going around about avocados that they don't need phosphorus, but they need lots of zinc. And when you give them phosphorus, which is really, really important for root growth, that is a benefit in trying to battle Phytophthora. But if you want, you can go ahead and send me some, just dig up some of the roots and send me a picture of them. Okay, and from once or twice, this is from Mark. Once or twice a year, I will dig in old straw into my garden to build up the organics. Seems like a good thing to do. Straw is pretty high in carbon. As long as it's really aged and starting to break down, you're probably okay, but you may want to add a little bit of extra nitrogen. Mark, are you growing organically? Yeah, so you may, what do you use for your organic material? You can unmute yourself if you want, so everybody can hear. What do you use for your nitrogen? I would add extra nitrogen if you were going to dig in straw, I guess, is the main thing. And then I missed a question from Margaret that she said the compost mulch builds the soil level. This eventually makes the tree lower than the soil. It should be pretty much breaking down. So I haven't seen that. How much mulch, Margaret, are you using?
2 to 3 inches at a time, but it doesn't seem to It does build the soil. Soil probably is a good 6 inches higher than when I started.
Really? And that's pretty interesting because I haven't seen that because it usually breaks down. And so that hasn't been my experience. I'd be interested if you sent me a picture of that.
Okay.
Thanks. And poor Mark can't unmute. So,
Okay, I just figured it out. Hi, Mary.
oh, okay.
Yep.
Great.
I was hitting the little icon instead of the upper right corner there for the unmute.
Okay.
So, a couple times a year, I'll get the mushroom compost, and maybe occasionally I'll go to Miramar and get the compost from them. So it's not strictly organic, but I try the best as I can, you know.
Yeah, you're not using pesticides.
No, I'm not.
Without needing to, right? Okay.
Yeah. And you know, I buy organic fertilizer by the bag from Grand Jettos. So that's it.
Yeah. So if you're using the mushroom compost is actually pretty high in nitrogen because I can't really speak for exactly what they put in it. When I had the lab, I used to do their analysis every week. But
okay, that's cool.
but it is pretty high in nitrogen, and so as long as you're using that, and the Miramar compost would be nitrogen stabilized, so
Yeah.
you're in pretty good shape. And I'm a firm believer in that there's a lot of right ways to do things. And so when somebody says, "Oh, well, that's not a good idea," you know, if it works for you, it works for you. So there's
Well, that's good to
lots and lots of right ways to do things.
That's good to hear about the mushroom compost with the nitrogen level, because you hear, well, it has too much salts. The salts are bad. It's spent. You know, it's completely spent. That's why they're throwing it out. But it's good to get your opinion on it.
No, I've used. I'm a fan.
Great. Hey, thank you for your presentation. It's very good.
So Ellen said that CCOF does not allow magic mushroom compost in organic. I'm not sure what magic mushroom compost is, but I think mountain meadow mushroom compost in organic or production. It could be because of the medicines, but here's what the deal is that in order to have anything allowed for from CCOF that is that isn't just like a straight product like chicken manure or something like that. It's a long process, and now in California, in order to have something certified, it is kind of arduous because we have to go through California Department of Food and Agriculture. So I only have one product that I bother getting organic certification on, and which is the composted mulch, for orchards. But I could see that maybe that it would be really difficult to get something like a mushroom compost because they're always, adding different things to it, including some inorganic fertilizers. But by the time you get it, I mean, all of that stuff's broken down.
Yeah, this is Mark again. I can agree. If you're doing strictly organic, like Ellen is, you don't have control of what someone else is putting into their batch. So it's out of your control. So
correct.
That would be the main reason, I think.
Yeah. And I know that I learned because I played around too with vermicomposting, and mainly just because I like to give classes on vermicomposting at home and like to have a supply of worms for that. And I had gotten this was probably 15 years ago, could be 20, but before I really thought it through, it seemed like a good idea at the time to get horse stable bedding from horses for the worms. And I didn't really know, I rode horses occasionally, but I didn't know how much worming medicine they gave them. Well, it was more like I had a vermicide going on because I killed every single worm by using it. So, they do give horses stuff, but by the time it goes through the mushroom process, I'd be shocked if they could pick up any of that. Because those medications really are broken down just by the heat. Any other questions? No? Well, thank you very much. I appreciate I'm honored that you guys asked me to talk, and
Thank
I'm
you.
thrilled that so many people are growing. I love growing myself, so I think it's really a tonic for the soul.
That was great, Mary. The information was incredible.
So yeah, and don't hesitate. Like I said, please do send an email. My email is on my website, which is agriserviceinc.com. And I always, like I said, I always like to talk about soil. So hopefully maybe next year we'll be in a different space with all of this craziness going on, and it would be fun to be actually out in the field and talk about these things, because I think it really does make a difference when you're standing outside and being able to point stuff out. I think it makes a big difference. So thanks again.
Thank you.
Okay, and John, I'll go ahead and email that to you right now.
Okay, sounds good.
Okay, take care.
All right.
Okay.
Thanks for everybody showing up, everybody. And
if I push end, am I kicking everybody off now?
Or else you can switch me back to host. You can switch me back to host, and then I can finish the recording too.
Oh, how do I do that?
You just got to click on me, and it says make them the host, or it'll have
make host. Got it.
Yeah.
There you go.
I'm host. Thank you very much.
Okay, and I'm going to send you that email right away.
All right, sounds good.
Okay, thanks. Everybody have a nice evening.
All right, Biddy. Well, thanks for showing up, and hope to see you around soon. We're going to end the show.